Did you know that only 30% of all test takers who attempt this OG advanced question get it correct, despite knowing the concept? Why do they falter? Because they are unable to translate. Hi, my name is Shweta. I am the lead Quant SME at e-GMAT, and today I'm going to help you decode such questions using the process skill of translate, which is one of the 7 process skills that everybody who aims for a Q50 must master. First, let's begin with a quick concept revision. So here you go. Say you have a number x which is written in its prime factored form. P1, P2, P3 are the prime factors, and you see powers on each of these prime factors. Then the total number of factors of x is given by this formula here, where you see the same m and an o, which were the powers of your prime factors. That's it. This is the concept that you need. If you are fuzzy about this one, then watch this linked video to refresh your concepts. Right now, let's come back to the hard question I talked about. I showed to you at the beginning. This. Now, before we go deeper into this, just pause the video and try it. And don't worry if you're scared of this, if you're not comfortable, I am going to solve this with you. Alright, I hope you tried. Now, how are we going to solve this? We will solve this in 2 parts. First, we're going to translate this entire question. Then we're going to solve that translated question. So the translation will be from English to math of each part here. The question stem, statement 1 and statement 2. Let's start with question stem. So here is the stem that you have. If x is a positive integer, how many positive integers less than x are divisors of x? Okay, so we're dealing with what? We are dealing with x, and x is a positive integer. So that means x can take these possible values. Now we need to find the number of positive integers less than x that are divisors of x. Let's look at it bit by bit. There were 2 main parts. What are divisors of x? Well, divisors is another word for factors. So these are factors of x. Now, factors of x also include x, right? This is where this part of the statement becomes relevant. This will then show you something. The question is asking us to find the number of factors, yes, but excluding x itself, because it has to be less than x. So what are you going to do? You will find the total number of factors of x, and from that, to remove x, you're going to subtract 1. This 1 that you're removing is x itself. That's it. Now, based on the concept you just discussed, I just gave you a recap of, to find total number of factors, you need powers of prime factors, right? So essentially, to be able to answer this, all you need is this. You need the powers of prime factors of x. That's it. So if we can find these powers of prime factors, then we can find the answer. Simple enough. Now, let's look at statement 1. Alright, so this is statement 1. Now, x squared is divisible by exactly 4 positive integers less than x squared. So you have slight difference here, but a lot of it is also common. See, it's along the same lines really. Slight change is what? Instead of saying divisors, it now says divisible by. And instead of providing information about x, it now gives information about the square of x. So your number is divisible by its divisors or its factors. That's what divisible means. So even when I'm talking about divisible by, I'm still talking about factors only. So this statement gives you information about the total number of factors of x squared. So this says that the total number of factors of x squared minus 1 is equal to 4. Again, why the -1? Because statement says divisors are less than x squared. So you're not going to include that one. So total number of factors therefore of x squared, if I am to include everything, then that's just going to be 4 plus 1, 5. That's it. So total number of factors of x squared is 5. Now let's similarly look at statement 2. So let's zoom into this. Here you go. This is statement 2. Now it says 2x is divisible by exactly 3 positive integers less than 2x. This statement is also like statement 1, no? Instead of x squared, it has 2x. So simple, straightforward translation. Total number of factors of 2x. This minus 1. Let's clear this, minus 1, this is 3. So from here I can actually get the total number of factors of 2x including everything. I can get that number, 3 plus 1 is 4. That's it. This is how you can translate complicated looking statements into simple math equations. Now the importance of this skill is so immense that we dedicated an entire module to it in our course, in the word problems course. So here we start with diagnosing your current abilities on translation on GMAT style questions, and then your abilities also on concept related questions. Now when you start learning your concepts, you learn a concept, you immediately do a practice quiz to cement that concept. Then another concept you cement it using a practice quiz, and then again. So this skill that I used so easily here in the video, you can very easily build this skill using the module, and it's super important. You're going to see the power when I show you something. So look, this is what really my question now has become. It's the translated version of the original question. Just pause the video and try this question once. Same story, but now a different version. Alright, I hope you tried. First of all, I'm very sure that you would have been a lot more comfortable solving this translated version than the original OG advanced question that we had. Let's have a quick solution here. Let's discuss this properly. Alright, so first of all, what is the total number of factors of x minus 1? Remember what we discussed in the concept. For this, all you need is this, powers of prime factors of x. We're going to see which statement can get us closer to that, or which statement can exactly give us what we want. So statement 1. Statement 1 says total number of factors of x squared is 5. So suppose the prime factored form of x is this, p1 to the power m, p2 to the power n, and so on. So what's x squared going to be? If I want to talk about factors of x squared, I have to express it in the prime factored form. No, so I'm getting it from x only. So this is going to be p1 to the power 2m times p2 to the power 2n, and so on. Then you apply the same concept. So total number of factors of x squared is going to be, this time you take the powers of x squared of the prime factors, and it's going to be 2m plus 1 times 2n plus 1 times so on. Whatever prime factors, howsoever many it has, you're going to just take them and multiply. Now this is given to us, it's equal to 5. We know it has 5 total number of factors, right? So now understand this. The left side is a product of positive integers. Why? Because see, if this is the prime factored form of x, then whichever prime factor it actually has, the power on that must be a positive integer. So here then at least these are all integers. I'm adding 1 to all of them. So you have to express 5 as a product of positive integers, and there's only one way of doing that. You can write it as 5 times 1. Now, of course, you can write 1 times 1 times 1. You can write as many as you want, but I'm going to show you why that's not needed. Look, so what does it mean for this product to be 5 times 1? It means 2m plus 1 is 5 and 2n plus 1. Sorry, this is plus 1. Let's fix this. Yes, 2n plus 1 is 1. From this one, you're going to get n equal to 0. So for every new one that I would write, it just means that the power of that prime factor is 0. It means it's not even a prime factor. You really are just going to get a proper value from here. 2m is 4, m is 2. What this means is that this m that you see on top here in the prime factored form of x, this is equal to 2, and all of these others that you would have beyond this, all of these other powers, they are just 0 based on what we saw here. So essentially combined, you can just say from both of these things, you can say that x is equal to p1 to the power 2. That's it. X only has one prime factor, p1, with a power of 2. And remember, you only wanted powers, no? You wanted powers of prime factors of x. Come back to the stem up top and you have that here. You're done. So this statement is sufficient alone, and this will help you reject some choices. Let me write that down here for you. So out of the 5 choices, I can now reject B, C, and E. Now let's look at statement 2. Now before we move on, tell me, how are you enjoying the video so far? If you've liked it, please hit the like button. That's going to tell me a lot. And I'll also request you to put in comments telling me how you think I can make this experience better for you. We are going to keep creating content like this to help you in your preparation journey. Make sure you subscribe to the channel so that you never miss an update. Let's move on. Alright, so similar theme at play here in statement 2. I've removed statement 1 so that you focus here alone. So 2x. Okay, let's think about the prime factored form of 2x. Say the prime factors are p, q, r and their respective powers are a, b, c. Same formula is going to work even now. You know that when you increase your powers by 1, you multiply all of that, you're going to get 4 because that is what is given to be the total number of factors of 2x, right? Now, how can you express 4 as a product of numbers? Because that's what the left side is doing. 4 can be written in 2 ways. This is where it gets interesting. It's either 4 times 1 or it's 2 times 2. And I have to think about both of those cases. So first, let me think about the 4 times 1 case. I'm just writing it here. So 4 times 1 case means that a plus 1 is 4 while b plus 1 is 1. Now again, this will just give you b is 0, and similarly all the other ones that if you want to put, it will still give you 0 power. So this essentially just means you have only one prime factor, a comes out 3 from it, and that prime factor is just this p. So in this case, 2x is equal to p to the power 3. So this is the first case. Let's do it similarly for the other one, then we'll see what inferences we can make. So this is about the other split, 2 times 2. What this means is that your a plus 1 is also 2 and b plus 1 is also 2. So from here, you're going to get two values. You're going to get the value of a and b, and both of these this time are not 0. a 1 and b 1. So 2x for you therefore is p times q with their powers being 1. Right? Now here are two possible ways in which 2x can be expressed. So you can find out the number of prime factors that 2x has, right? Let's just go deeper into each of these one by one. Okay, so here in the first case now, look, the left side I can see 2 definitely is a prime factor of the left side because it's 2 times something. So 2 is a prime factor of 2x. Now this is the right side and I can see p is the only prime factor of the right side, which is p cubed. Now if these two sides are equal, it has to mean that your 2 is equal to p. You can't have any other prime factor because otherwise the right side is going to have something else, the left side will have 2 and something else. That's not possible. Alright, so from here you get 2 is equal to p, and what that then means is that 2x is equal to 2 to the power 3. I'm just putting p here. So x is equal to 2 squared. And there you go. You have the power on the prime factor of x. And from here, you can get the number of prime factors, number of total factors of x as 3. So I'm writing that here. 3 total factors of x. From this, of course, remember in the original question we wanted a -1 also, but right now we're just seeing what gets us the value that we need. Similarly, let's dive into the second one now. So let's stay here. So 2x is equal to p times q. Okay, now this means what? Left side you can again see that 2 is definitely a prime factor because again left side right side equal, that means the right side also has to have 2 as a prime factor. So one of these, p or q, has to be 2. Suppose p is equal to 2. So from here then, if I take p is equal to 2, I'm going to get 2x is equal to 2q. When you simplify this, you're going to get x is equal to q. So here then is again the prime factored form of x. You can see its power is 1. And this time if you get the total number of factors of x, it's going to be 1 plus 1, which is 2. Now look very carefully. What happened when I did both of these cases together? I saw that one case is giving me 3 total factors of x, another is giving me 2 total factors of x. So this statement is actually giving me different things in different cases. So statement 2 alone is insufficient, and if I again go back and look at the choices that I had here up top, then now because statement 2 is also insufficient, I'm going to reject choice D, and my correct answer is here, choice A. And this is how you had to do this question. I'm just going to show you the whole of statement 2 here again. So without this translation, this question would have been crazy. I'm just going to show you both things, the before and the after, the whole journey that we went through. This is the question that you had before this convoluted language and everything that looks so confusing. And this is what you had after. Just look at these two. You can see how making this translation really changes the whole thing. It makes everything a lot more doable. This question here is very difficult, but the translated question, it's straightforward. It's just an application of the concept that you know. We did the review together, now you know the concept. So the key to making this difficult question easy was to master the process skill of translate. So here are my takeaways for you now. You have to correctly translate from English to math as you read a question. Every part in a question that you read, just simultaneously move from English to math. What will happen is you will stop just reading a question anymore. You will read not just to read it, but you will read to understand it. Now, to help you cement all of the learnings that I gave you today, here is some practice assignment for you. So look at this. I don't want you to solve this question, remember. My goal is just to make sure that you understand the question itself, that you can translate it. Okay, so here, for example, the first one says, what is the highest power of 2 that divides 1200? Do not give me the highest power as the answer. Answer in the comments. What are you going to give me? You will say that the highest power of 2 that divides 1200 is just the whatever simplified version you come to. So number 1. Similarly, for number 2, you will read it and you will just say it just means that and whatever, it just asks for that. So again, this question wanted how many trailing zeros it has. You don't give me the number of trailing zeros. You just say that it just means that I have to find this thing. So follow that format in your comments, and I'm going to evaluate all of this, respond to any questions that you people have. Again, I'll see you in another video. Don't forget to like the video if you enjoyed this and subscribe to the channel for more such content.